Hi, you'll find this on probably page 32 of your packet, at least if it's term 5 of 2022. Could be a different page otherwise. But we're going to talk about using algebra to solve word problems. And our first step is that we're going to define our variable. Does not mean I want you to give me a definition. It means we're going to say that we're going to let x equal the smaller number, for example. So I don't usually even write the word x or let, but I do write x equal the small number, that kind of thing. So you'll see that I model that for you. Then we'll set up our equation and solve. As we set up the equation, of course, we need to translate that equation. And we did that when we were working with expressions previously, so not a completely new concept for us. And then we're going to solve the equation. And then important step is at the end, when it's an application problem, particularly if it's not just talking about two numbers, if it's actually more application, then you want to make sure that you're giving multiple answers if it's required, and that you're using the proper units. So include units. So for instance, that might be that you give your answer a $sign, or that you tell me feet, and you can abbreviate, or miles, or days, or hours, or etc. Lots of different units that we could have, so that it really does answer the question. So you don't have to worry about units for this first set of problems because they just say finding two numbers. So we'll start out with the first one there because it's right on the screen already. And when we are finding two numbers, you're going to find it easier if we let the smaller of the two numbers be our x. It's also the one that's being referenced in this problem because it's telling me that the larger one is 4 more than the smaller. So the thing after the then is the one that's the reference. And so x, this is my let statement, my defining the variable. That's where I'm just going to say that x is my smaller number. And I'm just going to go ahead and say smaller. And then when I read that first sentence, it says the larger of two numbers is 4 more than the smaller. So 4 more than means we're adding 4. So I could say x plus 4, or I could have said 4 plus x. Since it's plus, the order is not important. I could write it in either order. So x is the smaller number, x plus 4 is our larger number. So now read on. If the sum, hopefully you recall that sum is the answer to addition, so that tells me I'm adding the two numbers. So if the first one is represented by x, and the second one is represented by x plus 4, and then I'm adding those two things, right? And then that will equal my sum, which in this case is 74. And then as I'm solving these, we have to follow our rules for multi-step equations. If we had to distribute, we should do that. In this case, we don't have that, but we do need to combine like terms. And then after we combine like terms, we have a nice two-step problem, and you may or may not feel the need to write the -4 under each spot. If you can do it without that, that's awesome, and with practice you should be able to do it without what I'm putting in blue. But if you would have wondered where did 70 come from, or how did I get 35, keep writing that. And you notice whenever I'm doing to one side, I'm doing to the other. Now, I'm down, I've solved it, now I'm down to the end. I need to give exactly what the problem is asking for. It says find the numbers with an S, right? Plural. So this is the first number. And then the second number, this would be my smaller, the second one, 35 plus 4 is 39. So then my final answer is 35 and 39. Now, because they're just numbers, I don't need to give any more units or labeling on that. But I do need to give two numbers, not just the number 35. Okay, we'll go from here to number 2. Right, so we are still going to be doing the same process, and we're still going to let x be our smaller number. So, and I'm going to start out writing that down. Sometimes people don't want to do that, but then they get stuck of like, oh, how do I set this up? Well, sometimes it actually helps to stop and just, this is going to help you focus. So x is the smaller, and then I have the other number is the larger, right? Well, the larger, it says, is 7 less than. Remember, less than is a turnaround phrase. We're going to switch that order because we're taking 7 away, that's 7 less than, 3 times the smaller. And if the smaller is x, then this is 3x. So 3x minus 7 represents the larger. And then it still says the sum of the numbers. So that smaller number, x, plus the larger number, 3x minus 7, is going to be equal to 71. Ah, hello, 61. My hand was better than my mouth there. Sorry about that. So 61. So now we're going to combine those like terms. Going to add 7 to both sides. So in the interest of space, I didn't write plus 7, but that's what I've done, is I've added 7 to both sides. Now I'm going to divide both sides by 4, and I get x is equal to 17. Once again, we need two numbers, so I have my smaller number, and then somewhere, wherever you have space, now you're going to do your larger. I'm going to go ahead and put it over here under where I wrote larger. So we're taking 3 times 17 and then subtracting 7. So 3 times 17 is 51. Take away 7. 7 less than 3 times, right? So is 44. So my two numbers are 17 and 44. And I could also quickly check that, yes, 17 and 44 do add up to be 61. So I'm not going to work through number 3, but I will tell you. So if you want to, I'm going to tell you the answer. So if you want to pause and try it on your own before you see the answer. But number 3, your final answer should be 21 and 85. And then number 4 is the wording is a little different on number 4. So I will show you number 4. I'm not doing very well on not doing every problem, am I? So at least you can fast forward if you don't need it or you think like, I got this, I don't need this. So in this case, x is the smaller, again, right? Doesn't look different yet. And then it says the larger of the two numbers is twice the smaller. So twice means 2 times. So if the smaller is x, the larger is 2x. And then this time it's not their sum though. That part wasn't so bad. But this time it doesn't say the sum. It says if 12 is subtracted from the larger number. So again, again, subtracted from is also a turnaround because I'm taking the 12 away from the larger number, which we just said is 2x. We don't know what it is, right? But we know we're calling it 2x, which is why it's really handy to define those variables. So if 12 is subtracted from the larger number, the result is, so equal 7 more than, so that's 7 plus the smaller number, which we wrote we're just calling x. So this time, remember, we have to treat things differently when that variable's on the other side, so we need to move the variable. So I'm going to take away 1x. So I'm just left with x minus 12 is 7. And then I just need to add 12 to come up with x is 19. And if x, the smaller number, is 19, and the larger one is twice, so 2 times 19 would then be 38. There is no reason for you to try to add them together to check things because we were not given their sum. So 19 and 38. So you have some problems. Those on the assignment, those examples are closest to number 1 and 2. Actually, problems 1, 2, and 3 on this are probably closest to 1 and 2. If you're curious for the next one, the high score turns out to be 98 and the low score 56. You can try that and see if that's what you come up with. When you turn the page over, starting with number 6, we still have application problems, but now they're not just talking about two numbers. So we're going to start to need to label things clearly. So we're going to have a little bit more to write at the end to make sure that we're fully answering the question. And sometimes we may only be asked about one person. Sometimes we may be asked for both. But sometimes we need to find the other person just in order to answer the question. So again, if I can figure out which one is being referenced or which one is smallest, that's usually the one I want to be my X. So in this case, Garrett has $1 less than 3 times as much as Liz has. So Garrett's money is being referenced in terms of Liz. So Liz is the one that has the least. So Liz is going to be our X. So X is going to be, we'll just say Liz. Liz is money. Liz is dollars. So then Garrett has $1 less than, well, we know less than, turnaround phrase, so I'm going to take 1 away from 3 times Liz. So that Garrett's is 3x minus 1. That is Garrett's money. And then together they have $179. So that is not just Garrett's money. That's Liz plus Garrett. So we're back to adding those two expressions together. And then we're back to a problem where we need to combine like terms. And then we're at a nice 2-step equation. Add 1, divide by 4. Oops, sorry about that. So then $45, we might think, oh, I'm done. Well, $45 is Liz, right? And the problem actually asked us for Garrett. So I need to do 3 times 45, take away 1. to get my actual answer that I was asked for. So then Garrett has $134. And oftentimes students will also give me Liz 45. But notice I've put Garrett's name with it, and I've also included a dollar sign. So we're not talking pesos or yen or any other currency. We're talking dollars. Okay, for number 7, now we have the Buffalo Bills and the Miami Dolphins, and the Buffalo Bills scored 24 more than twice the number of points that the Dolphins scored. So the Dolphins are like the reference. They're the one that we're comparing to. So, and they also have the least points. So X is the Dolphins. That's their points. And then 24 more than twice would be 24 plus 2x, or 2x plus 24, whichever way you're more comfortable with. They mean these two are the same. This is an either. This would equal the Bills' score. And then it says altogether the team scored 66. So if we add them together, you might find that second way, just because the x's are next to each other, might be easier to work with. And then same set of steps as the last problem, combine like terms, then it's a 2-step problem. And in this case, we are supposed to give answers for both. So I'll leave you to fill in the gaps. You can pause me now if you'd like to try it before I tell you. But your final answer should be that Miami has 14 points and the Bills scored 52 points. All right, and while they are not exactly the same, that should be helpful with number 3 and 4. Okay. And then starting with problem 5 on the homework, we are into area and perimeter, or not area, just perimeter, sorry, perimeter problems, and finding the length and the width when we know the perimeter. So first, let's consider that you've probably, and this paper is kind of assuming that at some point we have learned that 2 lengths plus 2 widths make up the perimeter of a rectangle. Right? There are 2 sides, the top and bottom, the lengths are the same, and the widths are the same. So instead of saying length plus width plus width, 2 lengths plus 2 widths is equal to the perimeter. The width is typically the shorter one, and so the width is going to be what we allow our variable to represent. I kind of go back and forth with this one. Sometimes I use x. Sometimes, since it's width and I've already got a formula, I'm just going to mix it up a little and use a w. I know. So if w is our width, and then it tells me in that first sentence, the length is 6 more than the width. So remember, more than means plus, not times. 6 more than means plus. So then w plus 6 is then my length. And the perimeter is made up of 2 of each of those. While at the top here I wrote 2L plus 2W, that is the same as if I put the 2 width plus the 2 lengths, right? But we're not going to use L for length. We're going to use this W plus 6. So I'm just going to go ahead and kind of keep it in the order I have it, that 2 width plus 2 of the lengths. It's going to be important that you remember to use those parentheses, is going to equal 24. And then now we actually need to distribute first. So we're going to distribute. We're going to combine like terms. We're going to subtract. And then we're going to divide. So we find out that the width is 3 inches. So I look at my problem, it told me that the perimeter was in inches, so I know that these dimensions are in inches. And then I can do 3 plus 6, right? Because it says the length is 6 more than the width. 3 plus 6, so our length is 9 inches. And I trust that you can do 3 plus 6 in your head. You don't have to write that on your paper somewhere. So for the next couple, I'm going to make sure that you can set it up, but I'm not going to work the problems out because I think at this point, most of my students, if they can have the right setup, they're golden. It's getting the right setup is the challenge. So in the interest of time. So number 10, we can let W be our width again. And then for our length, we'll have 4W plus 5. And then remember when we want to go all the way around the rectangle. So that would include 2 of the width and 2 of the length to get that 90. And then final answers here. So if you work those out, if you want to kind of test yourself to see how you're doing, final answers, 8 inches and 37 inches. So number 11, we've got one of those less than again, so don't let that trip you up. So again, if I let W be the width, and then 2W minus 3. 3 less than twice the width is the length. And then I need 2 of each of those. So 2 of the W plus 2 of the 2W minus 3, total of 18. So these are going to be small numbers. Come up with 4 centimeters for width and 5 centimeters for length. Remember that once you get length and width for perimeter, like you could think about this. If this is 4, and that's 4, and this is 5, and that's 5, and I add up all the way around, it should be 18. So if it's not, then that's bad news. Okay. So those perimeter problems will be helpful for the homework problems 5, 6, and 7. And then now we'll do a few problems about consecutive numbers. All right, so first off, consecutive numbers, the meaning of consecutive is that they are one right after the other. Right, so they occur in order, so one after the other. So if you did something consecutive days, I wore these pants for 4 consecutive days. Then you wore those pants 4 days in a row. So that's another way to think of consecutive, meaning one right after the other or kind of in a row, right? So if we are talking about consecutive numbers, an example of consecutive numbers, well, we are currently on page 34 in our booklet. So 34, 35, 36 would be 3 consecutive numbers. So when we don't know what the numbers are and we're representing consecutive numbers, we're going to call the smallest one x, or smallest as in the first one. So the first one is going to equal x. The second one would be one more than the first, so we'll call it x plus 1. And the third one is one more than the second one, because it's the next number, right? So, but this looks really jank if I put x plus 1 plus 1. So I can just let's just simplify that. If it's one more than the second one, then really what we're saying is it's 2 more than the first one. So any problem that is consecutive numbers, sometimes you'll only need 2, sometimes you'll need 3. You can have problems where there are 4 or 5, but not real often. But that's your kind of setup of what the different numbers are. So consecutive even numbers, they're still in a row, one right after the other. But consecutive even, if we started again with 34, then we would be going 34, 36, 38, etc., right? Like these go on and on and on, but just depending on how many we need. So in this case then, we still would let the first number be x, but now the second number, we see that they jump by 2's, right? The second number is 2 more than the first, not just 1 more. And then that third number is 2 more than the second. So 2 more than plus 2, then really in relation to the first one is x plus 4. So think about those 3 numbers, 34, 36, 38. If you looked at 38, it is 4 more than 34. And then the last type of consecutive number problem would be consecutive odd numbers. So odd numbers, for instance, would be like 33, the page we just left, 35, and 37. So even though the numbers are odd, they actually still jump by 2's, right? What's the difference between any of those next to each other? 2. So the first one is still x, second one is x plus 2, and the third one is x plus 4. So it does not matter whether the problem is consecutive even or odd. Your setup for those two situations is the same. What makes your answers even or odd has to do with the number that you were given, not something that you control. All right, so let's take a look at a couple of these problems. 2 consecutive numbers, so I only need 2, and it didn't say even or odd, so I used that first setup. So x is my first, and x plus 1 is my second. Or I might not even bother to write that down since I have it right here at the top of my page, but it would look like this. X plus 1 is 123, because this represents the first, right? And this part represents the second number. And it's their sum, which is why I put the plus sign in between them. Combine those like terms, subtract, and divide. So when we divide that by 2, I get x is 61. But remember, this is again plural, find the numbers. These are consecutive, so this would be 61 and 62. Are they consecutive numbers? Yes, they are. Do they add up to 123? Yes, they do. All right. So number 15 is very similar. If you attempt number 15, you should come up with 42 and 43. The setup would be the same as 14. And then number 16, we have two consecutive even. So we know this is x for the first and x plus 2 for the second. Notice we have that written up there above, and they equal 54. But the second one we go to plus 2 because it's even. So then 2x plus 2 is 54. Take away 2. Divide by 2. And I get 26, but again I'm supposed to have two numbers. So 26, remember not 26 and 27 because this time it's even. So then the next even number is 28. Or I could say 26 plus 2. And then you should kind of check, like, does that add up to 54? Because if it doesn't, something's gone wrong. All right, so those are a couple problems like that. And then let's jump down from there to number 19 for two reasons. Number 19 has three numbers, and it says odd instead of even. If you try number 18, you should get 44, 46, 48. Please keep in mind for number 19, the sum of three consecutive odd numbers, odd and even, set up the same as we talked about previously, or I talked about, I guess. So here's my first. My second is x plus 2. It's 2 more than the first. And my third is x plus 4. And the total is 57. So then I'm going to combine my like terms. That gives me 3x plus 6 is 57. Then we have our two-step equation, subtract 6, divide by 3, and I get 17. Okay, so 17, and it is an odd number, so I'm happy about that because I'm supposed to be finding odd numbers. And now I need three consecutive odd numbers. So then 2 more than 17, or you can just think the next odd number, 19, the next odd number, 21. And then you could double check that, yes, indeed, if I add together 17, 19, and 21, does that up to 57. So those examples are going to be helpful for 9, 10, 8, 9, 10, and 11. 8, 9, 10, and 11. That and what we put in our consecutive number spot. That's those are like 8, 9, 10, and 11 on the homework page, which is homework 12. At least that's what it's labeled currently. If this isn't 2022, you know, things could have changed. I'm going to help you set up one problem at the very end here. So it's your little reward for staying till the end of the video, I guess. This is from the homework page. And even if I would have done all of the examples, none of them quite set up like this. So I'll help you get this one set up and then allow you to finish it. So we're talking 3 consecutive even numbers. So I'm going to go ahead and write my little business over here that the first is going to be x, and the second is going to be x plus 2. Since they're even, we're jumping by 2's for evens or odds. And then x plus 4 for my third. So now in this case, we have sum, but it's not quite the way that we usually have sum, because it's not the sum of all the numbers. It's the sum of the smallest. So the smallest would be the x, and twice the middle number. So we're going to add the smallest, x, plus twice, so 2 times the middle one would be the second one, and it's called x plus 2. That's how it's represented. So the sum of the smallest and twice the middle is, so there's my equal sign, 20 more than the largest. So the largest is that x plus 4. We're adding 20 to that. I could have put the plus 20 at the end or the beginning. Hopefully both things, both ways I know. So this one we have all sorts of steps, right? We need to distribute, we need to combine like terms, then move the variable, then add or subtract, and then divide. So distribute, so I distribute it, and I went ahead and cleaned things up on the right side so I'd have less writing to do. Finished combining my like terms over here. Then I need to get those x's on the same side, so I'm going to move that variable. Don't move both of them, right? That wouldn't be helpful. So now you're left with a 2-step equation. Remember that when you get this answer, that is just your first number, and then you need also the next 2 even numbers after that. So I hope this is helpful, and I'll see you soon.